This program is brought to you by Emory University.
People talk about like your life flashing before your eyes, but that's not what happens to me. Every time I've taken a big fall climbing, the only thing I think is, wow, shouldn't I be done falling already? When is this going to end? I don't know why, but that's what I think of. When you're using a rope, you can climb something really tall like El Capitan, which is pretty cool, and you get to look out and have these great views, and it's pretty exciting to climb something that tall. And with bouldering, it's very simple. You don't need much equipment. And so you just bring your climbing shoes and a chalk bag, and you're ready for a day of fun. One of the numbers that climbers talk about is the ape index. And that's the difference between the distance your arms, your wingspan, the distance your arms can reach like this, and your height from the top of your head to the ground. And on average, people have those two numbers the same. The wingspan of a person is on average the same as their height. For a climber, you want your wingspan to be bigger. So I have an extra 4.5 inches of wingspan compared to my height, which is a really good number. My ape index is plus 4.5 inches. So I have some advantage. The climbing itself has a lot of just puzzles that have to be solved. It's not just strength or skill like in golf or billiards, but you really have to think about the different ways you can place your body and so on. And so the interesting thing is that naively you expect that the fall is going to hurt worse if the climber falls farther. But that's not really the important part. The important part is something called the fall factor. And that's the ratio of the distance fallen. That's the thing that you expect to worry about, divided by this total rope length going from the belayer to the climber. And so here you can see that the distance fallen is not that far. It's much less than the total rope length. And so that's going to be a nice soft fall for this climber. They're not going to be hurt at all. Suppose that this rope here were just tied off and attached to a wall. So you're only going to get stretched in this 8 feet. If you're 8 feet up and you fall, you're going to land 8 feet below for a total distance fallen of 16 feet. So that's, you fell 16 feet, and there'd be 8 feet of rope out. 16 divided by 8 is 2. So we say you have a fall factor 2. And the bigger the fall factor, the more of a jerk you feel when you hit the end of the rope, and the more strain there is on the climbing equipment. And so a fall factor of 2 situation is where bad things can happen. Equipment can break, or you can get pulled on too hard, and so you want to avoid that. It's a pretty simple rule. When this person starts climbing, he's going to make sure to put in pieces of protection so that if the climber falls, you avoid the very dangerous fall factor 2 fall. Actually, climbing El Capitan, I fell on a famous part of it called the changing corners pitch. And it's this overhanging corner that you're inside. And one of my pieces of protection pulled, and I fell quite a long way, about 40 feet, and fell out of the corner and had to somehow get back in. And I remember watching all of the equipment and rope go by as I fell, and just thinking, one of those things should catch my fall at some point. And you know the numbers for things too, right? So like all the climbing gear, you know how much of a force it should hold. And one of the things that I could see going by was a bolt, which is something that's actually drilled into the rock permanently. Those things can hold up a truck. It should have stopped me falling. I made sure to save the piece of equipment that stopped my fall. This is a brass nut. And so this is what caught the fall on El Capitan and saved my life. $10.
All right.
The preceding program is copyrighted by Emory University.